Hey everybody, Caleb here, live from my editing workstation. Just wanted to give you an overview on what we're going to go over in this video, and I apologize for the length in advance. So first thing we're going to do is enable the DMX plugins that we need, and then we're going to copy the engine content that we need into a new folder so we don't alter it. We're going to learn how to build a fixture, or we're going to import the pre-existing fixtures from the DMX library. And if we're building a fixture, then we're going to bring in the necessary components that we need and then wire them into a simple RGB panel light like you're seeing here with haze, that you can turn either the haze or the lens or the actual light emission off. We're then going to set an IP address in Unreal for our ArtNet to listen to, and then we are going to bring our fixture, our new fixture, and a pre-existing fixture into the world and patch it. We're going to use the fixture patch tool to enable in-editor DMX controls so that we can adjust and position our lights without going into runtime, which I actually discovered while making the video. And that is going to be it for this video. That is going to cover setting up, creating, and testing a basic fixture, and you should be able to run with that, but I'm going to have more videos to follow. So let's get into it. Alright, we are in Unreal Engine. I've got my water, and I hope you guys have some sort of drink, because this first video is going to take a bit. We are starting in a totally fresh file. Lighting tutorial 3. And let's go. It's just a blueprint, and then you can start in games just blank. Let's create. And by the way, one step in here that I didn't list is make sure that your NVIDIA driver is up to date. Otherwise, your lighting's going to look not like mine, and you're going to wonder what's going on. And I always do, and then I remember it's been 3 or 4 months since I updated my NVIDIA driver, and well, the new downloads, the new Unreal is talking to the new driver. So first thing we need to do is go to Edit, Plugins, and search DMX. We are going to look for DMX Engine and DMX Fixtures. I don't know if we need DMX Protocol, but it sounds relevant, so I always check it. And then we restart our engine. Once we're back in, we need to pull this up and then go to Settings right here, and then look for Show Engine Content and Show Plugin Content. Both of those have to be checked, and then go to Engine, Plugins. Well, I like to actually search through here instead of this because there's so many. So you're looking for DMX Fixtures Content. And then you, what I would do is right-click this and add it to your favorites. From there, you can go in your favorites. So what you need to do first is go to Content and create a folder for your copied engine content. The reason why we do this is you very rarely want to use engine content directly. You rarely want to reference it directly. The reason for that is if you ever go in to edit it, you're editing engine content that is not in this folder, in your project folder. It's in your Unreal Engine install folder. So if you go to start a new project and you think you're starting on a clean slate, you're going to be referencing that old engine content, and you might not want to do that. Now, if you have an update that you want to push to your own engine content, go for it. Go ahead and save that engine content. Just be aware that if you want to get that original engine content state back, you have to reinstall the engine, which takes a while. So we have our copied content folder. We're going to go to content, or we're going to go to our favorites folder up here, and then to light fixtures, and here's what we want to copy over. We can come back to this because I want to keep things relevant. So for this one, just go to DMX Materials, Masters, And then we're going to take this MD master and drag it into copied content and then say copy here. Now we can start building our own fixture now that we have this beam, because the beam is really the only thing we're importing from Unreal for this first approach of building your own fixture. So we're going to go back to content and we're going to make a folder for our new fixture. We're just going to call this panel light. And it's just going to be a square panel that emits light. We're going to right click and then blueprint class. It is going to be an actor. And then we are going to hit F2, name it. I'm going to call it panel light. And then we can edit it. Now what I like to do too is drag it into your world now. And then we can sort of see it being built. So while I'm here, there is a couple, before we start building this, and while I remember, there's a couple settings that you want to turn on if you're going to be using Unreal Engine as a visualizer. First is in project settings, or it's not in project settings, I'm sorry. It's in editor preferences, and you want to say use less CPU in the search bar. What this means is that if you go to other programs, your frame rate in Unreal Engine won't release its won't drop. Here was the other thing. You're going to want to go to Edit, Project Settings, Auto Exposure, and turn that off. That way you get the real light value. To add a couple things. First, we're going to add our body. So we're going to call this body. And then this is going to be a fairly flat rectangle square. And we'll make it sort of rectangular. There. Now we have our fixture body. We are going to add our lens. And this is a very basic fixture, by the way. We're going to be making more complex fixtures. One thing you could have done is just duplicated this, and that probably would have been faster. But actually, let's do that, because if you notice, my scale got messed up right here. And this in the editor, it does weird things when you the parenting is weird in this blueprint editor. So let's just click on our body and hit Control-C, Control-V. And now we have a body just like this. Let's turn our scale lock on and then drop this down just by a little bit. And then we can push it out past our light. Let's turn snap to grid off and then push it out a little bit past our light. So this will represent the face of the light that glows. We can get started building it right now, but I want to do two things in here. Let's drag this body onto the actual body and then rename this lens. And then the other thing I want to do is we can go ahead and add our rectangle light here instead of switching back. So let's add our rectangle light because we know we're going to need that. And then rotate so that it's 90. And then I always have to test my barn doors because I always seem to rotate the wrong way. That time I got lucky. And then we push that out. So we can go ahead and you can shape this if you want. I'm not going to. Go to event graph and we can begin building. Now the most important component here is our DMX component. Real quick, I wanted to make sure that your rectangle light is in fact parented to your lens. so that if you move your lens around for whatever reason. Anyway, so we're going to go to components and then hit add, and then you can just type DMX and it adds a DMX component. From here, we need to drag this on. Oh, there's no get or set. And then under variables, we need to create a variable that's going to be called output color. That's the most relevant. And then the type is going to be a vector. This is not going to be exposed. The other variable we need to make is a very specific one. We're going to call it fixture patch. And then under type, we search fixture patch, DMX fixture patch ref. Not this guy, but this one, the dark blue one. Click it and then expose it by clicking the I, so that when you set the address in your editor, it's visible. And then we can drag that fixture patch on and get to work. Now the first thing in this order, if we drag out from this DMX, we can find set fixture patch. That's going to run off our event begin play, and our event begin play fires as soon as the engine or simulation starts. If it's in the world, it fires this pin right here. It fires that once. So we're going to set our fixture patch, and then I believe this gets, that gets dragged to there and then converted. And then we have to click on our DMX component and then set an event for on fixture patch received. So let's click that. And now when this fixture patch receives a DMX signal that changes on its channels, this pin will fire. It won't be firing if you're talking to a different fixture, which is sort of interesting in how that works. So from here, we are going to drag out. We're actually not going to use these two. We're going to drag out here and say, or no, let's drag out from here. And say, just type in DMX attribute, and then you can find your node. Now there's two nodes I want to bring to your attention. The first is this, get DMX attribute values. And then the second is if you drag out type normalized, you can get normalized matrix cell values. Now, the difference between these two is this one's used for matrix cells, and it's actually nice because all of the values are normalized. So they don't come through 0 to 255, they come through 0 to 1, which is they just divide the 255 by 255 so that it comes through 0 to 1. This one, however, comes through 0 to 255. Now there is this, but this is, I've had interesting luck with this one. And perhaps it's just because I didn't hit that pin there. So there's 3 nodes that you have options to. I'm going to want to test this one first before continuing, because like I said, last time I tried this I had issues with this one. Now Unreal Engine, they've made a couple updates since then. So anyway, I'm going to start with this one because it's kind of the most primitive. So when this fixture receives a signal, this will fire. Now from here we can drag out, type find, and then we can get our attributes. So the first thing we're going to do for this fixture is just add a red and a green and blue. Note that we don't have to have a dimmer because our light intensity is going to be fixed at a certain value. We're just going to adjust the RGB values that it receives, and that's what's going to set its intensity. Its intensity can either be set on the set fixture patch or on the event begin play if you're confident in its brightness levels, or if it's something that's going to need to be adjusted, then I would want to set it to your probably to your event tick, because then you always have access to it even when you're not talking to that light. We'll get to that later though. We have our attribute values, so now we are going to create our output color. We can drag this in and then hit set, and then we can split this pin and just run all three of these integer values into this float value. The difference between these is that integers are whole round numbers and floats have decimals. That's all. So we're going to set our output color based on these three colors. And remember that when you're looking at Unreal nodes that things go in reverse. So first we set this event pin, and then these are its dependencies. So it reaches out, and if we unplugged this, it would have a number to get. But because we connected it to something, it runs backwards and it says, what am I? I am an integer. I have converted to an integer. My value is coming from my DMX attribute, which at the time being received read is at 50%. After we set our output color, we do need to divide it. So what we can do is simply drag out from our output color, hit set, and then set our output color to our output color divided by 5, or divided by 255. And what that will do is divide each of these numbers that are coming through 255, divide them by 255 to be 1. Now note that they are first converted from an integer to a float at 255. If we were to divide this integer value by 255 and then convert it to a float, what the float would see is 0 or 1 because it's coming from an integer. But here we convert the integer to a float first, and then we can divide it down to accurate resolution. I do like to put a print string here so that we can see our output color and what it is. And then for demo purposes, before we have anything hooked up, I actually do like to unplug these and just set a test color. So I'm going to do a lovely teal. So 255 on blue, 128 on green, 0 on red. So this will be our fake DMX value until we get DMX into here. So the first thing we can do is set our rectangle light intensity. That's done pretty easily. We're going to drag this in. And then the node that we want is, well, again, what I like to do is drag out from my subject first to get the most relevant node. So drag out from here and type set intensity. There we have that. Now note, I mistakenly added this in. This is going to be on our event tick, because what we're probably going to do is set our lights and then give them a color and then go around in our editor and set their intensity. This pin is only called when when you're changing values. So that would get clunky for trying to set our intensity. So we're going to right click here and type event tick. Sorry, I added that a little out of order there. But we might as well finish this up. you're going to make a variable. You could actually just right click from here and say promote to variable. And then let's just call this intensity. And then I like to convert this to an integer. And then you're going to have to replug that in. This is the integer means that when you're changing the value, it doesn't try to calculate all those steps in between. It just calculates the whole numbers. So it's a lot easier CPU wise. What is our warning? We do want to set a default value for this, so let's call it 10,000 and then compile again, and there we go. So moving on, we have our intensity set now. Now we set the color of our rectangle light, not the intensity. So we're going to drag out from here again and type set light color. There we go. What you're going to need to do is your output color that you just set, you're going to get it, and then you're going to drag out here and type make linear color. Oh, that needs to have context sensitive turned off, because this in computing wise has nothing to do with this. So we need to split this structure pin and then connect these float values where necessary. And then what happens if we don't do this is that our alpha layer will be 0 and nothing will show. So that's done. This is getting updated, and then this is getting called. Now what I want to do is do a little performance saving option here. So we're going to drag out from this event pin and type if. That's going to give us a branch. We're going to drag out from our branch, we're going to create a variable here, and we're going to call it is light on. And that means our actual rectangle light. If our light is on, we're going to go ahead and set this color. So this is a variable that we want exposed, so that we can affect it from the outside. And then you want its default value checked. You want by default the light to turn on, at the least. That's up to your personal preference. The other thing we can do is, if we're going to do performance saving and set our light color if it's off, we are also going to destroy the light if we don't want our light on. And that would best be handled in our event tick, because it's only done once. After that, we're not setting this light color. So let's drag out from our rectangle light, and then drag out from is light on, and then put a path here. Is light on. If it's not, there's got to be either I guess we can't set effects world. But we could just say destroy. And we need to say destroy component, otherwise it might destroy the entire actor. So then we're going to drag out, so if light is on, if it's not, we destroy the component. Let's test this real fast, because I want to make sure it doesn't destroy our entire light. So let's give our rectangle light a default value. Let's say 10,000. And then we'll save and go into our editor. Now we can see that our light's on. So if we hit play, our light stays on. If we go to our light and under details say is light on and hit play, it destroys our light. Even though our light's on. And now it's saving all of those resources. We don't even have... what's this? Oh, our event tick. So we need to handle this error right here. Event tick, we need to add in our is light on. If branch. So now only if our light is on will we try to change that value. Now if we go into play, it destroys our light, and then we have no errors. So that is good. The next step is to change the emission plate. And I like to do these in order of importance so that if an error occurs, it doesn't not turn on the light. We can rename this to body. So then what I want to do is, for our next step, bring in our lens. And then we're going to drag out from this and type set vector. I forget it kind of. Set vector of value on materials. Go ahead and click that. And then what this does is takes in an actor or component as an argument, and then searches for a name that would be in all of its variables. This is a little different than the dynamic material instance. I think it's a little bit more reliable. We're going to have to do some testing on this new 5.2 though, because I've had some issues on the last demo. Now luckily this is a big multi-part series, so if I have problems with this, I'll come back and notify you guys that this method isn't good, if some of the videos have already come out. So check the description for that flag right now, but if I haven't confirmed this method as totally not working at all, then go ahead and use it. If it is not working though, what you're probably going to need is a dynamic material. And so how that works is I haven't done it in a while. It's a little bit more confusing. You have to create the dynamic material instance. You have to identify the material index and the material variable name, and then go from there. So let's try this. We're going to do another Boolean. So let's do a branch, or you can type if. And then we're going to set both this and false to this branch. Because if we don't, if we do turn our light on, we still want to pass to our next step, regardless of what that decision was. So this condition is going to be called is lens on. So if our lens is on, then we set our vector parameter material. And then our vector parameter is simply equal to our output color. So let's just go to our content editor, right click, create a material, and we will call this lens. Let's be a little more descriptive. Panel light lens, and then it is a material. So let's go ahead and edit it. And then the first most important thing is we have to make a parameter value called DMX color. So we're going to hold 3 and then click, and then right click this and convert it to a parameter. Now we can give it a name. Let's call it DMX color. I like to call it DMX color because that's sort of the universal name that Unreal uses. So nice and easy to remember. We're going to plug this value into both our base color and our emissive color. And then what I like to do, actually you can hold control. I like to run this to a multiply node. And that would actually work best on the emissive color. The base color can be ran straight in, and then right click off of this, call it brightness, and then set this to a value of like say 1.2. So it's a little bit brighter than just emission. Save that, and then we can go to panel light and then type in here DMX space color. You can use spaces. The other thing we're going to do is another performance saving thing, where if lens is not on, then we also destroy that component. There we go. And the reason why this is important, it's not important for one light, but if you have many lights, you're doing a whole concert, it's gonna get crazy. Now, so what I would do is drag off here and then type SEQ. That creates a sequence, and this is a little more clean solution for all of this. So first we set our fixture patch. Done with that. Then we say, is our light on? Cool. After that, I don't want that to lead to the next one. I want to take a run of its own. I want this to always fire. We can do some cable management. There we go. So now we destroy our lens if lens is not on. And then here, is lens on? If it's not on, then we won't try that operation. So let's go ahead and test this. We can hit play. I actually didn't see the color come through here. Oh, the reason why is because this is on fixture patch. And we don't have any DMX. So while you're testing this and building it, you could just run this off your event tick if you don't want to get DMX set up yet. But we're going to need to do a sequence here in the meantime. Okay, so let's go ahead and hit play, and then on our item, I want to turn is light back on, and then we can also expose our is lens on, and then make sure that default value is on. So let's hit play, and then we should see our light turn. Kind of looks like it turned teal. We do have our output color. We don't have our lens color though. Now, one thing obviously we can do is lower our directional light intensity to be, like 1. That's good. But this lens is not lighting up. And I think it's just because if we go into our panel light, we have not set our lens to have that material. So lens, go to materials, and then you could either drag it in from your content browser or just type in panel light lens. Compile, save, and then test again. And there we go. It lights up teal. and so does the light. So that leaves us with our last item for this before we get to testing, and that is the beam mesh. Now the beam mesh is a really cool tool made by Unreal that looks like a beam but doesn't use volumetric light. So it just uses materials and camera vectors to emulate haze. Looks really cool. It actually looks way better than using a bunch of volumetric lights. A, because of performance, and then B, because the colors don't blend together like they do with volumetric light. So with volumetric light, when it comes in right here where they converge, you'll see a small bridge. And that's because there's a volumetric grid going on, and all of that light is lighting up this cell too. Well, that's not how real life works. I mean, these pixels will get lit up by a little bit, but not enough to bridge the gap. So what we're going to do is hit add, and we're going to type static mesh. This static mesh is going to be parented to our lens with our rectangle light, and then we can go into viewport, and then to view it, go to static mesh and type in sm_beam. Now, I told you guys don't use engine content. I'm gonna go against that here and go ahead and use this in the engine content folder and in its path DMX fixtures. Reason why is because this mesh is weird. I don't understand it, so I'm never gonna edit it. It also works just by itself, so why would I edit it? So let's add that as our static mesh, and then under materials, what I want to do is go to our copied content, and then we can what I would do is create a material instance of this, and then now I told you that I was having some issues. What I want to test is talking to this material instance. Maybe we need to be talking to the actual material. I've been told that material instances are better performance-wise than having a bunch of different materials. So let's test this again. What was happening is the mesh kept on getting unbound from its material, even though if you would go in here, it would still say that that's linked. So let's call this panel light beam, and then this is going to be moved to our panel light folder. And then from here, we can add it to our material. At that point, I would just drag it in. So there we are, we have our beam. Now I want to walk you through the material. I actually named this incorrectly, it should be MI. I want to walk you through the material, but I don't want to walk you through the material instance, because that's just a list. So this kind of shows you where stuff is and helps you remember it. So all we use is our emissive color and world position offset, and this is to shape the beam. That's to emit light. This is our DMX color value that we talk to, if we have to set that. And then over here we can find our max distance. So if we flip this light this way, we can see that it stops pretty soon. If we increase this distance, our beam will throw further, which is especially useful if it's a narrow beam. After that is the zoom. So here we can try to find a good window for this. We can adjust our zoom here, and all of these are parameters that are meant to be talked to. So now we have a beam, and then if you combine that with an extra 0 on the max distance, you can get quite a light. But remember that all that calls for more performance. So let's adjust our zoom back, and I'll walk you through some of the other variables. Now this one here, I have had it glitch on me once. It broke the texture. It's the best way I can explain it. So what this UV tiling does is it shapes your beam. I don't know if they intended for us to do this, but what I used it for is when you're making multi-instance fixtures and the beam meshes are right next to each other, but you still want to use them, bring this value down and then hit apply, and it will sort of reshape it to be skinnier. So you can see from the top view here, it's now a little skinnier than it was on the side, and it doesn't look as good, but if nobody's really looking at your fixture from this way, good example is with the GLPX4 bars. Their cells are so close together that you have to do this, otherwise your performance drops. So you can set this to like 0.1 and then hit apply, and then it's really narrow. And then it still looks fine from the side. So that works this way too. And there we go. So let's set these back and then continue the tour. DMX lens start radius, that's useful for what we need to do. So this one's like probably not that much. I made my light rectangle, so that was my bad, but I wanted a little bit of challenge to overcome. So there we go. We have a good light. Now notice that I want you to know this beam is square, even though it looks circle. It's just it's an interesting beam. It looks good though. This, I believe, is now set in real time. I haven't found much control over that parameter. I believe these three are also set, well, these two at least are set real time now. And then light intensity, you can adjust this. So if you add an extra 0 to this, you'll see it, probably. I thought you would. Yeah, you can. And then there is also DMX. Oh, that's max light distance. Oh, it's the same variable as back here. So when you change one, you change the other one. What this is though is max light intensity, and then you also get another zoom. And that's about it. What's this? This is new. Okay. So once you have that, you can go to your panel light blueprint. I just wanted to show you all the parameters of that. Go to your event graph, and then your next step is going to be to drag that static mesh in, which we can call beam. Drag it in, and then it's the exact same node. The only difference is now your beam is your argument instead of your lens. And in fact, you could actually merge these together, but I like to separate them by branch. So same DMX parameter name. That's cool. Let's go ahead and create a new branch and then make our last Boolean is haze on. And then connect up our nodes and then drag down from true, and then we should be done. So now if we compile, save, and hit play, we have beautiful teal light. And then what we can do is do the same thing we did with our other ones up here. So if haze is on, we do a branch and if haze is not on, we can destroy that component, destroy the beam component. And that's it. So let's go ahead and hit play. Make sure that is haze on is set to true by default. And then hit play and we're good to go. So the next step is to set up a DMX stream. So let's save all of our assets and then save our level. And then we will be back. Okay, so I'm booting up GrandMA. And then note that you do have to have DMX parameters built in, or DMX parameters active, and you can test that by going to setup, patch and fixtures, then make sure you have your parameters. If you don't have any GrandMA parameters, that's okay. There is a software called .2 on PC, and that can be used to generate one universe of DMX ArtNet for free. You don't need any hardware plugged in. So I have a patch already shown. I'm not going to repatch it. So what I have here is 10 RGB LEDs starting at address 1. And then I have an R2 wash. I'm going to go ahead and add a second one just for fun. And then we can go ahead and exit and save. And then what I like to do is go to that first group, so 1 through 10. And they're going to be rainbowing at full. And so now I have this DMX window up. I can see my values being sent. So I do need to make sure that everything else is set up. So I want to go to Control Panel and then go to Network and Internet, and then make sure that my USB adapter is good. Now it says it's connected to a network. I go to Properties, Internet Protocol version 4, and then you can see that I have a ArtNet approved IP address. The ArtNet approved ones are 10.0.0.1 and 2.0.0.1. So once you have that, I'm plugged into a Power over Ethernet switch. It doesn't have to be Power over Ethernet, but any network switch that you plug into will be perfectly good to activate that network for ArtNet. What else you can do is, and this is kind of like experimental, it doesn't always work, you just plug your Ethernet into another computer, or you use a USB and plug it into itself. And that will sometimes activate the ArtNet just enough to activate the network just enough to pass the ArtNet. But the most reliable way I've found is to connect it to an external switch, even if that switch is not connected to anything else. So we can get out of here and then go to MA Network Control, and then make sure that we are on that station IP, and then go to network protocols and then make sure that this button is checked, ArtNet output active. Once we have that, we can test our ArtNet stream by going to ArtNetometer, and then I can see it there. In Unreal though, we are going to go to Edit and Project Settings and set our DMX IP address. So we can go down to, basically go to the bottom, and you'll usually find DMX. Input port. Now we do what we need to do. IP address. And then external universe start. So we notice we can't see it as soon as we turn external universe to 0. And then we are just 2 steps away. So if we go to this panel light and go to our fixture patch, we'll find that there's nothing here. So we need to create our own DMX library, and I want to do that in our content folder. So let's right click DMX library. We can just call this DMX library. And then double click that, and then here is where in the real world in the virtual world, we explain what fixtures we're using and where all of their channels line up. So this would be like building the DMX functionality into the fixture. So we're going to start in libraries, fixture types, and then say new fixture type. Double click it. This one's going to be a generic RGB. And then we're going to add mode. And it's just going to be called 3-channel. If you're doing a multi-instance fixture, then you click that. We're not on this one. We're going to go to add function and then hit red. We're going to make a function for red. We're going to make a function for green. We're going to make a function for blue. What these correspond to are these values here. So this is how it's going to know to get that value from the DMX ArtNet system. That's all we need to do in here. We also need to go to fixture patch and then hit add fixture RGB. Now, one thing we did not do in project settings is specify our extern start. So let's go back down here. Extern universe start. Usually most programs start their extern, their first universe is on ArtNet universe index 0, not 1. So we have to set this to 0. And then how we test the DMX to see it is we click on this DMX here and hit activity monitor. Now we don't see it. Oh, I added this under an output port. That's why. So let's delete this. Input port. Now we do what we need to do. IP address. And then external universe start. So we notice we can't see it as soon as we turn external universe to 0. Now we get our universe 0 index. Now that we have those values and can see them up here, we can exit out. And now we're safe to set our fixture's address. So let's go in here. DMX library, that one. Fixture patch is our first light. And then what we can do actually is hold Alt and then drag and then make multiple lights. And let's go ahead and add 4 more. Okay. So now we can set all of these lights. I'm trying to get to a cool angle. And there is a way, I will show you guys how to use the patch tool. In fact, I'm just going to figure out how to do that right now. With the magic of video editing, I will suddenly know how to do this. Well, I'm glad you got that. I just spilled an entire cup of water all over my desktop, into my computer. I'm literally soaked. Alright, well, if anybody missed that spectacular moment, I just spilled 950 milliliters of water on my keyboard and mouse. Anyway, everything's alright. It missed my Graname wing, so that's good. But I'm completely soaked. So anyway, I did some digging, and it seems like how I made these fixtures, you can't use the patch tool. So I have 10 RGBs. I went ahead into my DMX library and added 9 more RGB LEDs. But if you use the patch tool and say address incremental, they do not address incrementally. Those are all, they're all 0. So these we have to set manually. If you use Unreal Engine's prefab lights, you can actually patch these to RGB, but they'll work a little bit better than you would think. So we go to, we select all 6 of these. I'll show you how to get these in a second. Well, I'll show you them now. So you can always find it in the browser and browse to asset. So yeah, this came from our engine content. So you just search, probably because I was in content, I need to be in all. So you search wash LED, and then you can drag this in. I'll show you these more in a little bit, but if you want to use the addressing tool on these, that does work. Patch tool, and then you say RGB 0, and then address incremental. And when you're done, if you go to their fixture patch, you'll see 0, 1, 2, 3. Now, hey everybody, I know this part got confusing, so I want to explain it a little bit. I left it in because I did want to show you that you can use the patch tool to address fixtures that don't have all of the parameters available for that and might mismatch, in case you don't want to add new fixture types just to add new lights. So if you already had all of your RGBs patched, I'm going to patch these now by the way, but if you already had all of your RGBs patched and then you want to add some of these lights, you can patch an RGB to it and it just won't use the pan and tilt parameters. It'll just be an RGB light. But that got confusing, so I wanted to clear this up a little bit. That yes, you can address these to static RGB lights, but if you wanted to make a profile for it, the reason why I didn't do it is because I didn't want to build a whole profile right here. So I built this one real fast. This is a wash light with any number of channels to it. This one has 9 because, and I just made this up. I don't think this is any actual real fixture. But if channels 1 was pan, 3 was tilt, and then both of these were 16-bit in addition to dimmer being 16-bit, and then your red, green, blue value fell on the next values, then that would be technically a moving light profile that could work for this patch. So then after you save that in the same way, and then you add your wash. So this is a 7th wash. I'm actually going to delete this. And then just Control C and Control V or Command C if you're on Mac. And as many fixtures as you need. And then you simply patch it the same way. So address all 6. Out of habit, I'm going to do them in order. I don't think that's necessary, but probably. And then use the patch tool and a patch to wash 0. And then you can see wash 0, 1, 2, 3, 4, 5. So that's how that's done. Let's test our LEDs here. Oh, I remember there was 2 things we need to do with this blueprint. The first is interestingly enough, so we have to set these. Then interestingly enough, I'll say, I'm wondering if we will see, yeah. So that was interesting. My previous version of doing this, I did not have control while I was in editor. And you'll see if I drag out from a panel light now, I probably don't have control in editor. I might, there's a chance. No, I don't want to create a new one. So I don't have control over this, but I can flash control to it. Watch this, DMX, patch tool, and say address incremental. As soon as I do that, I don't know what happens, but now I have control in editor, which is really cool. Maybe I add a component to it. Doesn't seem like it. I don't exactly know why it does that, but this is a cool discovery to find while I'm recording this video for you guys. The other change we have to make is in panel light. One of these is not public, so there we go. All 3 of these have to be publicly viewable. Intensity has to be publicly viewable, and fixture patch has to be viewable. Once we have that, our system is complete. And then we can disable this print string or just remove it completely. So that is it. I'm going to call it on this part right here. Interesting that the world partition shut that off. On my next video though, we're going to talk about how to build your own light in Blender and then bake the lighting so that it looks good. We're also going to go over bringing in prefab lights and modifying them so that they can look good.